Okay, guys, I'm going to take up this homework assignment. This is Unit 4, Handout 13. It's question number 3. I got a delta-delta transformer, ratio's 2 to 1. Look, another one of these crazy series loads, okay? And that capacitor there is the power factor correction capacitor. And again, it's in series, so the intent here is to improve the power factor and increase the current for whatever reason, okay? And looks like we're trying to correct it to 90%, and it's going to lag, okay? So let's see if we can figure this one out. We'll start with the easy stuff here, guys, and we'll see if we can calculate, as much as we can. E phase primary, okay, it's delta, and it looks like it's 575 as a line voltage, so this will also be 575 volts, okay? E phase secondary, 2 to 1, okay, guys? So 575 divided by 2, 287.5 volts. E line secondary, there's the 287.5, so 287.5, okay, guys? It's delta, 287.5 volts. E phase load, I got 287 going from there to there. That's going to be divided by root 3. 287.5 divided by root 3. Okay, so we're going to hit divided by root 3. 165. 166 volts, really. Okay. 166 volts. Okay, let's see if we can still figure this out. I phase load. Well, look, I only have 2 of the 3 devices, so let's see if we can figure out what's going on with this load here. We're just looking at one of them again. We're going to draw it over here as a phasor diagram. It won't be power phasors, though, even though this is, kind of a power factor correction question. On these series loads, you must draw impedance phasors, okay? So R, because it's series, okay, you can do that. R is equal to 15 ohms, right? And XL is equal to 15 ohms, right, guys? And that capacitor, it's definitely there. I don't know how big it is, but it's going to sit right here. That's the cap, right? And that's a single phase cap this time because we're looking at one of these loads. So we're looking at one of these little guys here. I know it's all complicated. Hey, guys, here's going to be your Z, okay? And I have to try to figure out what that is. But look, these caps are correcting this thing to 0.9, okay? So what I'm going to do is figure out Z. It's going to be 15 divided by 0.9. 15 divided by 0.9 because, that hypotenuse is always the adjacent side divided by the power factor. 16.67 ohms. Okay, guys? And what that's, I don't know if I need it, but I'm going to finish this diagram. I'm going to probably need it, okay? So I'm going to calculate X here. And it's going to be this squared minus this squared, right? So that squared minus 15 squared equals root equals, looks like this guy here, 7.265 ohms, okay, which is going to allow us to calculate that cap, the single phase cap. The cap, guys, is going to be 15 minus 7.265. So let's try that. 15 minus 7.265, 7.735. Okay, and that's good because I'm pretty sure it's going to ask for that. But now that I've drawn this entire little phasor diagram that represents this little single phase bit here, okay, we're going to figure out I phase load. And E phase load is 166, and Z is 16. Let's try that. 166 divided by 16.67. 9.958 amps, okay? And that would be, if I clamped on right there, It's really important, you know, to keep track of what I'm actually calculating. I line secondary, that current right there. Guess what? It's Y. Okay. I phase secondary. That would be right there, right, guys? And it's going to be, you know, this is 9.958. So this is going to be 9.958 divided by root 3. Okay, because those two are going to come together and get that. I know I keep saying that, right? I keep going over why I'm doing it. Hopefully, guys, that part, you know, the root 3 part, you know, you should be getting it every time now, okay, by now. If you're not, then you got some work to do, okay? You know, figuring out the root 3, whether it's Y or delta, that should be like this by now, okay? I don't know if it is or not, but it should be. I'm going on I phase primary, guys. And it looks like the ratio was 2 to 1, so I'm going to divide by 2. 2.875 amps, okay? And that's be here, right? 2.875 amps. And now I line primary 2.875 times root 3. Whoops, not divided by, times root 3. 4.979 amps. And that'd be here. 4.979 amps. Okay? And XC each, look. And that is each. 7.735 ohms. Easy, eh, guys? I mean, there's only, what? Couple hundred things you got to try to remember to get all these things straight. All right? I know. It's a lot, but that's why there's a lot of practice, guys, and I want you to do your practice. So keep trying. You're going to have a test soon. Test 3 review, guys. To get ready for the test, you should be doing Unit 4, handout 14. Giant amount of questions there for you to try. And if you can do the review, you will be able to do the test, okay? But you have to do everything very carefully. After the test, we'll start some motors and alternators and things like that, all right? Because that'll be the end of the whole 3-phase craziness and all the math and everything. Motors and generators are going to be boring, and you're just going to listen to me talking about all these different kind of weird AC motors, okay? But we'll worry about that after the test. Have a good day, guys. You're almost there.